Assignment alcohols and halogen alkane, question 22. This question is about one chloro, one bromo, and one iodobutanes. And they can be made like one chlorobutane can be made by adding potassium chloride to a mixture of butane, one ol, and sulfuric acid. Explain why it is not possible to make one iodobutane. So the same reason is there. What is the reason if you have one bromo? Like if we have a potassium iodide is there, so this potassium iodide, it will react with sulfuric acid. First it will produce potassium hydrogen sulfate plus hydrogen iodide, but the hydrogen iodide which is produced contain iodide, and iodide is like it a strong reducing agent, and as a result it will reduce the sulfur to lower oxidation states. So the same reason that why we cannot produce the iodobutane by this method, because when sulfuric acid react with hydrogen iodide, sorry, when it react with potassium iodide, it will produce hydrogen iodide, and in hydrogen iodide, the iodide is strong reducing agent, and it will reduce sulfur to lower oxidation states. So as it reduces the sulfur to lower oxidation state, like it might produce sulfur dioxide, hydrogen sulfide. So these are the lower oxidation states. And the hydrogen iodide will not react with alcohol to undergo a substitution reaction. One iodobutane is prepared by adding an iodine in a small portion to a mixture of a red phosphorus and butane monol. When all the iodine has been added, the mixture is reflux. In this reaction, iodine reacts with phosphorus to produce phosphorus triiodide, which then reacts with butane 1-ol to produce form 1-iodobutane. Write an equation for each reaction. State symbols are not required. So first what happened? The iodine reacted with phosphorus. It will form phosphorus triiodide. Equation must be balanced. So we have first the phosphorus is reacting with iodine and it will form phosphorus triiodide. Then iodine is a diatomic molecule. And the phosphorus is having a molecular structure. So like usually P4, P6, P2. You can write that, or even without, you can write as an atom, because if many are there, then atom, then we have to write a balance equation for this. So we have 3. So if I put 3 here, then it will be 2 and then 2 phosphorus. So that's the first equation. Then this phosphorus triiodide reacted with butanol, which is C4H9OH, and it will produce iodobutane, 1-iodobutane C4H9I, plus phosphoric acid is there, so H3PO3. And this will be 3 molecules here and 3 molecules, so the equation will be balanced. This is the equation for the 2 reactions which happen or occur. The rate of 3 halogen alkane with water are compared. 2 centimeter cube of ethanol was added. 3 drops of halogen alkane are separately added. 1 chlorobutane was added to test tube A. 1 bromo was added to test tube B, and 1 iodo was added to test tube C. 2 cm³ portion was silver nitrate. So whenever we add a silver nitrate, if a halogen alkane contained chlorine, what will the observation? It will be white PPT. If it was bromine, it will be a cream color precipitate. And if it is iodine, it will be a yellow PPT. Explain why ethanol is added in each test tube. Like in the beginning, as you can see, in each test tube, we add ethanol. So because what happened, this is aqueous silver nitrate is there. Ethanol is like, here it is used as a solvent. Ethanol is, because halogen alkanes are not water soluble, because they cannot form a hydrogen bond with the water. So halogen alkane does not dissolve in water. So this ethanol is like a co-solvent. Co-solvent means it can dissolve silver nitrate, it can aqueous silver nitrate, and it can also dissolve halogen alkane. Like it is acting like a co-solvent, a medium in which the two substances can mix with each other. So what is the purpose of adding ethanol? Ethanol is actually acting like a co-solvent here, which can dissolve both aqueous silver nitrate and a bromo alkane. Because silver nitrate is a polar substance, and the halogen alkane is a non-polar. So we want to mix them together, so we can mix them together in a solvent which can dissolve both. So that is the reason we add ethanol first to dissolve both of these reagents. Give the name of organic product which is formed in all three reactions. So there will be a substitution reaction, like we have butanol is there, C4, uh, uh, sorry, bromo, chlorobromine, 1 chlorobutane is there, C4, H9Cl, C4H9Br. So we were having C4, H9Cl, C4H9Br, and C4H9I. And we are adding a silver nitrate, AgNO3. Aqueous is there, water is there. So what will happen? Silver is combining with chlorine, silver is combining with bromine, silver is combining with iodine. This will form silver chloride, silver bromide, silver iodide. And what happened to C4H9? In each case, so that will combine with OH, the water, because it is an aqueous. All of them are aqueous. So water molecule is there. So the OH will combine with C4H9, and as a result, it will produce butanol. So butanol will be produced because like this C4H9, in which chlorine is removed, it combined with OH of the water molecule, as these substances are aqueous. The halide ion formed in each reaction with the silver nitrate give a precipitate, give a color of a precipitate form in C, and state symbol for ionic equation for the precipitate. So because the C is like iodine, and with the iodine, what is the color of the precipitate? It will be a yellow PPT. And it is forming silver chloride, silver iodide. So the ionic equation for formation of silver iodide, there will be a silver ion and there will be iodide ion. And ions are aqueous, so aqueous, solid. Dilute and concentrated aqueous ammonia, as I just mentioned, if we have a chloride precipitate, what will the observation in test tube A? When dilute is added, so it will dissolve, the precipitate will dissolve, and the precipitate will dissolve. Here no change, the precipitate does not dissolve, and here no change. Because C is iodide and A is chloride. So chloride with dilute and concentrated aqueous ammonia, both will dissolve. but in iodide, both are insoluble, does not dissolve. Give the order in which the precipitate will form, because as I mentioned, iodide can easily, iodine can easily break the bond as it's a longer, like larger, um, like greater bond length is there. So as a result, what will happen? It will be C will break down first, then it will be B, and then at the last it will be A. State how the bond polarity of a carbon halogen vary, and explain why bond polarity does not determine the rate of this reaction. Bond polarity means like the distribution. When halogen is attached with chlorine, it is attached with bromine, and which is it is attached with iodine. So in terms of bond polarity, chlorine is more electronegative. So this will have more negative partial, this will have less positive, negative and positive, and the iodine will have the least positive and negative. So they're saying why the bond polarity is not affecting the rate here. So rate of a reaction depends on bond strength rather than bond polarity. And bond strength, when we compare the bond strength, the strength of a bond, the iodine, carbon iodine is the weakest. This is weaker, and this is also weak comparatively, but the weakest is carbon and iodine because of a greater bond length. So the rate of a reaction did not depends on the bond polarities, it depends on the bond strength. And because the carbon iodine bond is weaker, that's why it will break down easily. And the test tube C, the reaction will happen or occur much faster as compared to test tube B, and the test tube B will happen faster than test tube A. Is it clear? Then in part C, when halogen alkanes are heated separately, concentrated potassium hydroxide in ethanol, so means alcoholic medium, it will form elimination reaction. The same gaseous products, same gaseous organic product form give a structural formula of this product. So when potassium hydroxide is added to halogen alkane, it will undergo elimination reaction. So if we have all the cases, it will produce a butane gas. Why it will produce a butane gas? Because like we have the first halogen alkane, say this is a skeletal formula for three of them. The first one was 1-chloro, the second one was 1-bromo, and the third one was 1-iodo. But when potassium hydroxide or alkali is added in alcoholic medium, elimination reaction will happen, like it will lose one carbon, will lose a halogen, and the adjacent carbon will lose a hydrogen, and they will form a double bond with each other. So there will be double bond here, double bond here, double bond here. So this will be the product. Which product is the structural formula we have to draw? In a structural formula, we show the minimum details. So we can say CH3 is there. Then we have CH2, then CH, and then CH2. Because like 2 hydrogen, 1 hydrogen, 2 hydrogen, and 3 hydrogen. So this is the structure of butane. And what is the type of the reaction this happens? Whenever alcoholic is there, this will be an elimination reaction. Give a chemical test for this product and state the color. Because it's an alkene, so what is the test for alkene? We can add aqueous bromine and it will decolorize or changes from orange to colorless. Because the test for all the alkenes, we can test by using a bromine bottle. In part D, all three halogen undergo a substitution with ammonia. Write an equation for initial reaction when 1-iodobutane react with ammonia. State symbols are not required. So how it can be done? If we have one iodobutane, like we have CH3, CH2, CH2, CH2 and I, and it is reacting with ammonia, which is NH3. So one of the hydrogen will be left, and then NH2 will take possession of this iodine. So the product will be CH3, CH2, 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 NH2. Means it will produce butylamine, and plus one hydrogen and combined with iodine, it will produce hydrogen iodide. If we use excess of ammonia, then only mono substitution happen. But if we use a limited supply of ammonia, then as a result, it will produce multiple substitution, like until all of the hydrogen will be replaced by the carbon chains. Butylamine, like this is a butylamine, which is formed with butylamine formed also react with one bromobutane for further. Suggest a structure. So if butylamine, which is formed here, it reacted with again one bromo. We just need a product, but I will write the equation first to give you an idea. So we have like CH3, CH2, CH2, CH2 and I. It reacted with butylamine, the first one, the product of the first reaction, CH3, CH2, 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 NH. So this whole carbon chain will take position of the second hydrogen. Then what will the product? It will be CH3, CH2, 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 NH, because one of the hydrogen removed, then it will be CH2, 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 and CH3. Plus the hydrogen which is removed combined with iodine produce hydrogen iodide. So this product will be there. This is a structure. But we don't have to write an equation. We just have to draw the structure of this product. In question 23, bromoethane react with concentrated alcoholic ammonia to produce ethylamine. However, in this reaction mixture, ethylamine further reacted with bromoethane to produce diethylamine. This further reaction of ethylamine can be best limited by carrying out with what? Like how we should do this experiment if we want to like minimize the multiple substitutions, then what we should do, we should use excess of ammonia, because if we use excess of ammonia, then the further reaction will be stopped. In the preparation of one bromobutane, if we are producing one bromobutane from butanol, so butanol converted to, it is preferable to react sodium bromide with 50% sulfuric acid rather than concentrated sulfuric acid. The main reason for not using a concentrated sulfuric acid is because it is, so what might be a reason why we don't use too much sulfuric acid? Because what might happen if too much sulfuric acid is there, sulfuric acid will be reduced and the hydrogen bromide will be oxidized to bromine. If too much sulfuric acid is there, then what might happen? Because first, when we have sodium bromide, NaBr, and we react with sulfuric acid, it will produce sodium hydrogen sulfate plus hydrogen bromide. This hydrogen bromide may react with sulfuric acid to form bromine molecule and sulfur, or this hydrogen bromide may produce sulfur dioxide, bromine molecule. So what might happen, because if too much sulfuric acid, like if we use concentrated sulfuric acid, too much sulfuric acid is there, then they will reduce the bromide ion to bromine molecule. Sorry, oxidize the, because this is -1, Br is -1, so it, and this is 0, so it will oxidize the bromide ion to 0, or sulfuric acid which contains sulfur, the bromide ion may reduce the sulfur present in a sulfuric acid. So the reverse argument is also possible. That's why we want to minimize that. So B will be the Right answer. Question 25. The reaction between aqueous sodium hydroxide ion and halogen produce an alcohol is classified. So the reaction between sodium hydroxide ion and the halogen to produce an alcohol. How we classify? So we call that as a nucleophilic substitution reaction. And whether this nucleophilic is homolytic or heterolytic, so because it's produce a nucleophile, because like what will happen if we have a halogen alkane, partial positive and negative. So when this bond will break, it is not producing a free radical. If it was producing free radical, then it will be a homolytic bond breaking. But because it is producing the ion, like both of the electrons are taken by the halogen, so that's why it is a heterolytic bond breaking. And the type of a reaction whenever OH attack, that is a nucleophilic substitution. Like OH will form a bond and a halogen will break the bond. Some organic molecule either on their own as a part of a mixture contribute to some unpleasant odor. So this is a structure question that we'll do next session. So this was exercise related to alcohols and halogen alkanes. Any question or a doubt related to this part?